Hi, this is Jack from Maths Forge, and in today's lesson, we're going to be doing inverse proportion. So let's take a look at our first example. Here we're being told that x is proportional to 1 over y squared. Now, another way of saying this is x is inversely proportional to y squared. Putting the y squared in the denominator makes this relationship an inverse proportion. And what inverse proportion means is when one value goes up, the other value goes down. So if x was to increase, this value here, 1 over y squared, would decrease. And this is achieved by putting the second variable, y, as a denominator. So let's go ahead and answer this question. When x is equal to 12 and y is equal to 3, express this relationship using an equation. So the first thing you have to do is set up an equation with your constant of proportionality. And this looks like the following for inverse proportion. We're going to have x is equal to k over y squared. So you can see where there was a 1 here, I've replaced it with a k, which is the constant of proportionality. And now we can begin substituting in our values for x and y. So here we're told x is equal to 12 and y is equal to 3. So it's going to be k over 3 squared. And simplifying this gives us k over 9. Rearranging for the constant of proportionality, we multiply 9 onto both sides to isolate the k. This now gives us 108, which is equal to k. So our constant of proportionality is 108. We can now rewrite this equation with the constant of proportionality substituted in. We get x is equal to 108 over y squared. And now this is the relationship that exists between x and y squared when they are inversely proportional and you have an x value of 12 and a y value of 3. So this is our answer. And if we check our answer, there it is. We'll do another 1-star example. Again, we can see that x is inversely proportional to y cubed. So when x is equal to 20 and y is equal to 2, we must express this relationship using an equation. We first begin by writing x is equal to k, the constant of proportionality, over y cubed, and then substitute the values in for x and y. So x is 20 when y is equal to 2. So it's going to be k over 2 cubed. Simplifying this further gives us 20 is equal to k over 8 because 2 times 2 times 2 is 8. Rearranging for k gives us a value of 160. So now we can go ahead and rewrite this equation out with k substituted in. X is equal to 160 over y cubed. And this is the relationship between x and y cubed when they are inversely proportional given these x and y values. And if we check our answer, there it is. Now let's do a 2-star example. Here we're being told that x is inversely proportional to y when x is equal to 3 and y is equal to 63. What is x when y is equal to 7? So the first thing we have to do is to get the equation that shows the relationship between x and y. We first begin by writing x is equal to k over y in this case, and then we substitute the initial values for x and y. So x is equal to 3 when y is equal to 63. Rearranging for k, we multiply 63 to both sides, and this gives us 189, which is what k is equal to. We now rewrite this equation out with k substituted in, so we have x is equal to 189 divided by y. Now we can go ahead and answer this question. What is x when y is equal to 7? Well, x is equal to 189 divided by 7, and 189 divided by 7 gives us an x value of 27. So this is our answer, and if we check our answer, there it is. Now let's do a 3-star example. Here we're being told that x is inversely proportional to the square root of y, and when x is equal to 28, y is equal to 4. What is y when x is equal to 8? So we first begin by structuring our equation. X is equal to k over the square root of y, and we substitute our initial values for x and y. So x is 28 when y is equal to 4. So we have the square root of 4. We then simplify this first. So we're going to have 28 is equal to k over 2 because, of course, the square root of 4 is 2. Rearranging for k, we have to multiply both sides by 2. This now gives us 56, which is equal to k. So we can go ahead now and rewrite this equation out with k substituted in. So we're going to have x is equal to 56 over the square root of y. Now that we have the equation that gives us the relationship between x and y, we can go ahead and answer this question. What is y when x is equal to 8? So I'm going to replace x with 8, and then this is going to give us 56 over the square root of y. Now rearranging for y, since it's a denominator, I'm going to first have to multiply both sides by the square root of y. This cancels out the y on the right hand side, just leaving us with 56, and on the left hand side we end up with 8 multiplied by the square root of y. And whenever I'm multiplying by square root, I always like to put it second. Now to rearrange for y, we have to get rid of this 8, which is being multiplied onto it. So we're going to divide both sides by 8. This is now going to give us the square root of y, which is equal to 56 divided by 8, which is 7. Now, all we have to do is rearrange for y by getting rid of the square root symbol. The opposite of square rooting is squaring. So I'm going to square both sides. This now leaves us with y is equal to 7 squared, which is 49. So, given the relationship that exists between x and y, when x is equal to 8, y is equal to 49. And if we check our answer, there it is. And that's it for the lesson on inverse proportion.